Hey everyone, welcome back to yet another episode of YinsPy. And today we're going to be talking about how to load up the housing data from URL and how to get that data into the Python Jupyter Lab environment and what are some basic visualization that we can do. So without further ado, let's get started. This is going to be a beginning level Python tutorial episode. So without further ado, let's get started. So today's agenda is going to be like this. Let me make a text box. And I'm gonna say agenda. It's gonna be download data in environment, load data in Python, and plots. First things first, library. I'm gonna import OS. I'm gonna import tar file, and this is particularly for TGZ format. Last but not least, I'm gonna do URL lib. Okay, so now before I make the definition of the function, let's define something. Let's define some path. This is going to be housing root, and then that's going to be a giant URL. So I'm going to copy paste from my notebook. Boom. All right, next thing is going to be housing path. Okay, and that's going to be the OS path joined between data sets and housing. The last is the URL path. So we're going to say housing URL, and that's going to be download path, download root plus datasets housing TGZ. So those are the paths. Once that's defined, I can define my function. So I'm going to call a fetch housing data function, and in this function I need a housing URL, and that's going to be housing URL, housing path, and that's going to be housing path. Now we define the function. So it's going to be get the data and extract. There are two parts, and then return. So with that being said, let's do OS, make directories. That's going to be housing path exist. Okay, let's set that to true. And the next thing we need is TGZ path. That's going to be OS path join housing path housing TGZ. Okay, and we need this URL lib request. We're gonna give it a URL retrieve, and the path is gonna be housing underscore URL TGZ path. Okay, so that's getting the data. Now we want to extract it. So housing TGZ is going to be tar file package. We're going to call the function open. This is going to be the path is TGZ path. And then what we have is housing TGZ extract all. Extract all. That's going to be path housing path. Okay. Last but not least, housing TGZ close. That's technically speaking the final step. So we're gonna put it there. Boom. Okay, so once I run this function, I will be able to trigger all these commands. And specifically what it's doing is it's going to this URL to download the data. And once it's downloaded, it will save the data locally, and you will be able to see in one of these folders here. In particular, there's going to be a new folder defined, and there's going to be the actual housing data in it. So let's run that function. That's defined. Let's run this fetch housing data function, and let's run it. Oh, I have a typo. True should be defined like that. Boom. Okay. Now we have this data folder here. If we click in, we will see this TGZ, but we'll also see the extracted CSV file that is here. Now I can open that, and that's going to be the preview of what this data looks like. For example, we have longitude, we have latitude, we have housing medium age, that sort of thing. So there you go. This is going to be the first step. Let's get the data into our environment. So we're going to come back here. We're going to say check. Now, the next thing we want to do is we want to load that data into this Python notebook environment. So what we're going to do is we're going to say import pandas as PD. We're going to define a function. We're going to call it load housing data, and it's going to be a housing path. Specifically, that could be housing path. And we need some sort of a function to extract the data, specifically is CSV, according to the path defined up here. So we're going to define CSV path. And we can just use this OS, path join. Okay, and that's going to be housing path, housing.csv. Okay, now we're going to return something, right? We're just going to return panda read CSV and then whatever this path is. Boom. All right, so we have the function. This function is going to go to this particular directory on your left-hand side, and it's going to grab that CSV, and then we need to assign that to some object. If we don't do that, it will just print the CSV, and then it won't be memorized in the environment. So here we're going to give it a name. Let's just call it housing, and then we call that function housing data. Boom. Okay, so this housing should be a data frame. Let's print that out. Let's do an info. That's your data. So you can see the class is a panda data frame. We have these many entries. We have these many columns, right? These are the column names, and that's how big it is. We can also do first few rows. Let's say 3, and that's going to give you the first 3 rows. In Python, the index actually starts from 0. So you actually see 0, 1, 2. Boom. There you go. Now, let's do some basic but fancy visualization. Here, the first column is longitude. The second column is latitude. What if we create an axis that is 2-dimensional, and each dimensional will map the longitude and latitude just like how it's mapped on the surface of the planet, except it's 2-dimensional, not a surface of a sphere. And we can just print some labels. We can give like a medium housing price or something like that. So let's execute that idea. First things first, we're gonna import some library, matplotlib pyplot as plt. So first we're gonna call data, housing, and then we need a plot, okay? In this plot function, the first thing we need to define is the kind. If we want to mimic these dots on the planet, on the surface of a planet, I think the kind is going to be set as scatter, and that's going to be more similar to what we want it to look like. If you set it as line or something else, then it's going to look like some random wiggles that's all over the places, and we don't want that. X, just define an X label, right? And that's going to be longitude. Y, that's going to be latitude. Alpha is actually the opaqueness. So if you set alpha is 0, then it's like see-through. If it's alpha is 1, it's like there's no opaqueness. 0.4 is just a good amount of opaqueness, but not a whole lot. Next, what do we have? We have the C is set as median house value. And the median house value better be somewhere here, right? Boom, median house value. So let's print that. And what else do we need? We need a CMAP. And the CMAP is going to be plt get CMAP, and then we're going to call it this jet function. And then for now, just don't worry about this jet part. It's just set up for this map to look like what we want to look like. Color bar, that's going to be true. And then we're going to give it a fixed size, say 10 by 8 just to make it bigger. Boom. So now it looks like that. Essentially what we just did was we have this two-dimensional plot. One dimensional is longitude, one dimensional is latitude. We're able to plot a scatter plot of all the houses, and I believe this is California. And we give it the color label, right? So we have this color bar that's presented on the right-hand side, and we're having this color map, CMAP, that is essentially coded with a label defined as the median housing value. Since it's a housing value, it's going to be treated as a continuous variable. So it goes to as high as this number here, which is in red color. That's 12330, so that's 500K. And as low as below, this is 100K. So somewhere here, it's coded in blue, and that's below 100K. So as you can see, a couple of the houses here and here on couple of houses here and here, that's obviously higher real estate price. And as you get into the mainland, you see lower and lower housing price. Definitely use Python, highly recommend to do that with all of your coding project. And that's definitely a good way to start looking at your data. So there you go. I hope you liked today's episode. If you enjoyed the channel, give a like and hit that subscribe button, and I'll see you in the next episode.